One of the main applications of adding fractions, which I hopefully want to try to do in class, is adding when you're cooking. I keep bringing that up, but that's if you're adding, say, 2/3 cups to 1/4 of a cup, you need to know how to do that. You need to kind of know how much you're going to get back. Okay, but the question is, how do you add two fractions if they have different denominators? If you had 2/3 cup and 1/4 of a cup, how do you add them? And I know you guys probably know. You're thinking of what? Common. Yeah. That's another method we're going to use later. This is called the straightforward way because you don't have to find a common denominator. But I want you guys to try to draw this out. We're not the best at drawing. I'm certainly not good. But let's draw a cup. Okay. Good. We're going to fill it 2/3 of the way up. Now, I know that's probably not perfectly 2/3, but you get the idea. It's more than half. Might go a little bit further up there. So 2/3 cup of water or milk or whatever. Now, let's say you're combining that with another cup. And now I'm going to make it 1/4 for now. Hey, you want to make it 3/4? Yeah, we can make it 3/4. It doesn't really matter. We'll fill it 3/4 full of purple slime since it's Halloween. Okay. Purple slime. So listen, guys. It's a little bit more than 2/3, but the problem is, if it was 2/3 plus 1/3, we would easily know that that's 3/3 because they have the same denominator. But since the denominators aren't the same, we can't say that it's, certainly we can't say 5/7, right? That doesn't make any sense. You can't just add the numerators and denominators. You can already look and tell it's going to be bigger than a cup, right? If you add those two cups together, it'll definitely be more than one cup. Yes?
Could you simplify before you do that? Because it would be one, it would be
What would you simplify?
Well, I was thinking cross simplify, or like the 2 and the 4.
No, that's multiplication. This is adding. That's a good guess. Okay. Here's what I want you to see, and right below each of these cups, I want you to draw another cup. Whoops. Basically, what we're going to do is divide the cups. So let's look at these denominators. This one's 4 and this one's 3. What happens if you multiply those? 12. Okay. So on the left, hold on, just take a look at this. All right, on the left, instead of writing 2/3, I'm going to write 8/12. It's the same thing. So I still have 2/3 of cup of water, but it's actually 8/12 cup. Okay, you could actually divide this into 12 pieces. I don't know if I can do it. I'll try. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see that we've got 8/12 of those. It's not the best, but you get the idea. In the same way for the other cup, we can divide it into 12s. What would 3/4 become in terms of 12? Yep. 9/12, yes. So we'd have the same exact amount of purple slime, but it's just divided into 12s. 9/12 instead of 3/4. Again, I could divide that into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if they have a common denominator, meaning we just multiply the denominators out, we now see we have 8/12 over here. We have 9/12 over here. How much total liquid do we have? Anybody want to answer that?
17/24.
17 over 12.
Not change the
Right. In other words, if we simplify that out and made it into a mixed fraction, be 1 and 5/12. Okay, what would that look like? Well, if we wanted to draw that, there's 1 full cup of whatever, it'd be purple and blue, right? Plus, you have another cup, and it would be 5/12 full, so it'd be 1, 2, 3, 4, 5 of those. And it'd be like that. And yeah, it'd be both colors, purple and blue. And so all you got to do is multiply the denominators. That's it. Whoops. Didn't mean to do that. So if you multiply the 4 and the 3, you'll have the same equal number of parts, and you can add the numerators. That's what we're going to be doing today. First example will make it a little bit easier. Let's do 1/2 plus 1/3. This is, again, the straightforward way. There's a shortcut. This one doesn't have a shortcut. Some of them do. But first thing you're going to do is multiply the fraction, the left fraction, by the right fraction denominator. So what's the right fraction denominator? 3. You're going to take the left fraction, and you're going to multiply the top and bottom by this number. So what that's going to look like is we're going to have 1 over 2 multiplying by 3 over 3. In other words, we're turning it into 3 over 6. Okay, the next step is to take the left denominator, in this case it's 2, and multiply the right fraction by that number. So over here we're going to have 2 over 2. Okay, so that's your step 2. I'll give you guys a second to copy this. So next step is to combine those by adding the numerators. So first of all, when we simplify this on the left, we get 3 over 6. That's why we learned to multiply first, because you multiply straight across. 1 times 3 is 3, 2 times 3 is 6. 1 times 2 is going to give us 2 over 6. Good. So we get 2 over 6 here. So this makes more sense. If we have 3 out of 6 pieces of a cup and 2 out of 6 pieces, we get how many pieces total? Anybody? 5, combining by adding the numerators. And then sometimes you have to reduce, not in this case, okay? 5 and 6 do not reduce. But again, let's actually draw a picture of this 1/2 and 1/3 and see why we ended up with that answer. So here's I'll go back in there in just a second. Here's a 1/2. Okay. Here is a 1/3. Now right off the bat, if you just look at what you have, it's hard to tell how these would add up, right? We don't know what would happen if we combine these two. But if we write the left one as 3 over 6 and the right one as 2 over 6, let's divide it that way. So here's 1, 2, 3, 4. That's divided into 6 pieces. 1, 2, 3, 4, 5, 6. Yep. And over here we can divide it the same. 1, 2, 3, 4, 5, 6. So as you can see over here, we have 3 out of 6 pieces. And over here we have 2 out of 6 pieces. Now it's real easy to see. If you add the 3 over here and the 2 pieces over here, you'll end up with 5 out of 6 pieces. That's terrible. I'm drawing that again. Wow. Yeah, let's try this. Okay, here we go. You end up with 5 out of 6 pieces. So it actually would end up going up to here. More visual. So that's why we multiply the denominators. Let's do a few more, and then I'll let you guys do it on your own. You guys want to pick some fractions? Oh, I'm sorry, I told you I'd go back up. Where did you need to go? Right here? You already got it? Okay. You guys pick some fractions here. Okay, what were you going to say?
3/6.
4/5 over 3/6. Fair enough. Okay, so I'm going to start with the 4/5 and multiply it by what? No, just the denominator. 6 over 6. Okay, the 3 over 6 is going to be multiplied by what?
5 over 5.
Good, 5 over 5. You're multiplying it by the left denominator. Notice I didn't talk about this, but if you multiply like by 6 over 6, for example, that's just 1. Okay, 4/5 times 1 is just 4/5. So you're not changing anything. What did you say? 24 over 30, good, for the left one. And then 15 over 30 on the right. Now the bottom members are the same, so we have the equal number of total parts. We just add the pieces. 24 plus 15 is, good, 39. That's why, guys, you're just combining you're just adding the numerators, not the denominators. You're just adding the number of pieces, not the whole number of parts. And that is, I'm having so many issues today.
The only thing I'm funny is like, you know how you post it out. I'm just gonna be watching this and just like
It happens. All right. So step 4, we're going to reduce this fraction. Can it be reduced?
Yeah.
Why do you know that?
Because you have more than 30.
Well, not necessarily. Like 11 over 10 can't be reduced. They have to have a common factor. So what's the common factor between 39 and 30? 3. So we're going to divide the top and bottom by 3 to reduce it, which becomes 13 on the top and 10 on the bottom.
Okay, so
11 and 10.
11 over 10 can't be reduced. Wouldn't it still just be 1 cup and then another cup on the side with only one up?
Yeah, you're right. Exactly.
So it sometimes can't be reduced, but it still is always going to be a
Improper fraction.
Yeah.
That's not reducing a fraction. That is changing it to a mixed number. 11 over 10 would be 1 1/10.
There you go. That's what I was saying.
Yep. All right, let's do one more. Get you guys to pick this one again. I will say this, okay? I'm going to pick the first one. The first one's -4. It's going to be positive, 2 over 5. I did this for a couple reasons. I wanted to use a negative, and I wanted to use a whole number.
So
what were you going to say?
you just add the 4 by the top? Once you put -4 over 1? Yeah.
Yes, -4. So if you have a whole number or an integer, you need to write it over 1. Okay, so when we do that, we see that, you know, we can still multiply well, let me just ask you guys. Now that we've done that, -4 over 1 times what? The right's denominator. Yeah, the right denominator is 5, so we're going to multiply it by 5 over 5. And then the 2 over 5, we're going to multiply by what?
1 over 1.
Yeah. Now, you don't have to do that because 1 over 1 doesn't change anything. But for the sake of, you know, following the steps, we're going to multiply it by 1 over 1. So, now let's do -4 times 5. It's going to give you that numerator, which is what? -20. Okay, denominator's 5. On the right, we have 2 times 1. Yeah, which is just, okay, this is, there we go, 2 times 1, which is 2, and then 5 times 1, which is 5. Okay, so now we just add the numerators. What's negative 20 plus 2? Please get this right.
Negative 22.
Negative 18.
Oh, because, yeah.
Negative 20 minus 2 is negative 22.
86.
What's the bottom? Is it 10 or 5? Good. The denominator stays the same. Can this be reduced?
No, we can't. Nothing that goes into 5 goes into 18.
Good.
So we